I think that's enough of that. We went from 1950s jazz, easy jazz to 1950s rock and roll.
Okay, so this is Ramalama. So we're introducing the boring AI companion. It's something myself and Dan and several others have been working on the last few weeks or so. So I'm Eric, and I'm guessing you guys all met Dan. You all know Dan from the last talk if you were here. So I'm just going to go through some of the goals of the project. One of the goals we speak about is making AI usage boring. We were talking about John Masters in an earlier talk, and one of his favorite phrases around ARM was "make ARM boring," and I kind of stole that, to be honest, from John Masters. And what we mean by that is AI tooling can be very complex, and what we mean by that is for the most simplest use case, that is basically a one-liner install and a one-liner run command, and you're in business. And by the way, I semi-stole that with John Masters' approval because he's actually a vocal supporter of this tool. So. Another goal of the project, again, as Dan was talking about in the last talk, is containers have one in terms of usage, in terms of infrastructure, etc. A lot of the world in enterprise revolves around containers. So we aim to be OCI-centric by default, so in two different ways. So in terms of providing a runtime environment as containers, so this could be your ROCm, NVIDIA, Vulkan, etc. And also one that's more interesting, in my opinion, is, in our opinion, is providing models as OCI artifacts. And we'll go through that later. Another goal, have any of you guys seen this Demon Slayer series? I haven't, but I thought the logo looked really, really cool, so. But another goal, it's falling in line with Podman and lots of other tools, is to be daemonless by default. So a lot of the AI tools, they kind of demand a client server infrastructure, but with this tool, say if you're using it for a desktop use case where you're just typing something on the command line, it spins up its own process and there's no single point of failure. But you can also run it as a server also. It's just daemonless by default. Yeah, so this kind of goes back to the OCI-centric qualities we're going for. So, in the last talk, originally OCI artifacts were built for containers, right, running in the container runtime. But now people are finding OCI registries useful for many use cases. Again, referring to the last talk, Bootsy is a typical example of that, where not only are you packaging a small user space here in a container, you're containerizing the kernel, the whole operating system, essentially. And yeah, I have some other examples written down here. We containerize Podman machine VMs, KubeVirt, although I haven't used that, and there's something called Crun VM, which is another way of basically containerizing an operating system. And we aim to containerize AI models also via Ramalama. I was on that one already. Okay, so another goal is to have native GPU support. So yeah, you can run AI workloads using your CPU, but it's obviously not the most optimal way. So we're hoping to be compatible with all the various GPU types out there that are useful for AI, be it an NVIDIA graphics card, an AMD one, Apple Silicon device, Intel, the list goes on and on.
You know, one of the interesting things in the AI world is actually how to turn on the GPUs on your individual machine. And we had talks this week talking about issues about doing that. So one of the goals of this project is to find container images that have to sort of discover what the native GPU that you have on the system is, and then download a container image with the appropriate libraries for actually activating that GPU. So taking that guesswork out of a person's hand and actually building it into the tooling.
Yeah, exactly as Dan said, and another thing, when the layman runs an AI tool, sometimes you might be SSH'd into a box, you don't even know what the primary GPU is, or you're just on a random. Let's say you start a game on your PC, right? You don't have to pick your GPU, but with a lot of AI tools out there today, you kind of have to know your hardware and specify, I'm on this hardware, run using this configuration. But Ramalama should. It's something we're working on. Do a quick query of the system and auto pick the primary GPU for running the AI workload. In terms of OS support, right now, as of today, we support Linux x86, but probably as soon as next week, we're aiming to support running on a macOS machine via Podman machine, and we're also looking into possibly native macOS support also, if you want to run it natively on macOS. I'm sure we'll have a Windows solution as well via Podman machine or WSL, but this will be the focus for the next few weeks or months. This is another way we differ from a lot of the AI solutions out there. We don't really want to lock you into any specific type of repository for models. There's kind of a lot of competition in the space at the moment. Only last week I saw GitHub released some new data store for models, which I haven't even looked into. But the two most well-known ones today are Hugging Face, which is kind of the de facto standard. Ramalama is a really cool one because they made it easy to use and push-pull from. But we think there's a lot of potential in OCI container registries because a lot of people just have the infrastructure set up for that already, and they don't have to play with firewall rules. They don't have to spin up new infrastructure, and it just works. It's well suited to multi-gigabyte files, so we think there's a lot of potential there. So I'm going to show you a quick demo in a minute, but this is basically how it works. You run Granite Code is the new open source IBM model that's focused on code. It's really cool, actually. I recommend you trying that out if you haven't. So you run a Ramalama run, Granite Code. It'll pull that model via one of the three repo options. The default as of today is Ramalama, and then you'll basically start your model. So I'll just show you a demo of how that's done. So so here I've ran Ramalama run Granite Code, and I'll say write me a Python program that tells. This is a 3 billion parameter model, so it's not super intelligent, but it's useful for testing. Llama from Meta, they released a 405 billion parameter insane model last week, so this is a lightweight one. Write me a Python program that tells me about Rochester. I don't have a GPU on this machine, so it's not exactly going to be what I'm disappointed in is it's not writing Python. But whatever. Write me a Python program that does addition. Okay, just want to do something. So now it's writing some Python. That's actually not down to the tool. That's more down to the model. If I ran a different model, I'd probably get different results. Yeah, what else did I want to show you? Yeah, just to install, it's just a one-liner command. It's nice and simple. We'll probably package it eventually, but it's not packaged right now. You can serve models. This is what we mean by boring. Like everything's like 2-3 words, click enter, and you're serving a model. This dry run thing, this is kind of handy if you want to. It just prints out basically a podman command that shows you how that model could be served, and you could actually convert that to a quadlet format or whatever. There's a very cool tool in the containers GitHub namespace called Podlet, and you can give it that and it'll dump out a quadlet format of this. Now, I would inspect it to make sure it's correct, but...
So basically what's going to happen when you run the Ramalama command, it will go out. If you don't have a container installed previously that understands your GPU, it will download that GPU-based container image, and then it will run. It'll also go out and pull down the model that you want to work with to your system, and then basically start serving the model. By default, a run command will just run a chat bot with the model running in behind, and serve will basically put up an API server that you could have other tools then query against the model. But the bottom line is it's just a 3-line command, I mean a three-word command, and you're suddenly up and running with an AI model on your laptop. And if you're on a Windows or a Mac machine, it'll be happening inside of the VM running on the system. So it's that simple. That's why, again, that's why it's so boring.
And if you've ever used like Podman before, you'll notice the syntax is very like Podman. That's deliberate. So the difference in this example to the previous ones I show you, by default we pull from the Ramalama registry, which is Ramalama. One thing they did really well is they make it really easy to use. So if you want Granite code, it's literally like Granite-code. But in this case, I'm pulling Hugging Face, and we have support for that. And you can check what model. These are some models I downloaded in the last few days. You can see there's 5 different models from the Ramalama registry, and one from Hugging Face. Excuse me. And that's kind of it. It's very early development. I just wanted to show you some of the high-level features. So anyone that's tinkered around with AI tooling in this space, basically like 99% of the open source tool, they're powered by Llama CPP under the hood. So our tool is no different. It's some very lightweight Python that calls this tool.
Yeah.
If you, oh, go on.
This is sort of us revealing our dirty laundry here. Is we probably have a couple hundred lines of Python code that is all calling into this library, and this library is doing all of the handling of the models. So really all our tool is doing is pulling down the containers and executing Podman under the covers, and then executing this tool to actually serve up the models. And so, there's really, the really cool thing is that this project was thrown together. Originally it was a bash. He wrote it in bash to first demonstrate, and we rewrote it in Python to make it easy for people to contribute to. And all we're really looking for, yeah. Well, the guy that wrote this is the genius behind it. It's not,
Yeah. There's very few, although this is kind of the tool that does all the heavy lifting for everything, there's very few people that use this directly, because this is like AI for rocket scientists. It's definitely not boring at all. It's very exciting. You have to be a bit of a guru to use it directly. But yeah, we're looking for contributors, so feel free to join us. One of the reasons we wrote it in Python is a lot of the AI world revolves around Python, and yeah, as Dan already referred to, it's very easy to contribute. Like, it's a couple of hundred lines of Python at the moment, so like if you looked at the code base now, you'd probably understand the whole thing in a matter of hours. I had a guy who was made aware of the project this morning. I was speaking to him. He was interested in contributing this morning. He pushed his first PR literally an hour ago, and I merged it just before the talk, so it's really accessible if you want to join it. Another thing where we differ from other tools is we really want to push an open ecosystem. We don't want to tell you to use Ramalama repository. We don't want to tell you to use Hugging Face repository. We think probably that OCI registries will win the race maybe in the enterprise use case because the infrastructure's there already. So, but we're not going to tell you. We're trying to create an open ecosystem and not lock you into any specific type of infrastructure or repositories. Yeah, so I got that working in one of the old bash versions of the tool. Basically how I did it is just I query dev sys, like in code, to try and, on a best effort basis, try and detect the primary GPU, and then we'll poke holes in Podman depending on the GPU. Like I know that this GPU you're talking about, it needs access to this file, dev/kfd. I don't know what that stands for, but it needs access to that file. Depending on the GPU, we poke enough holes in the container to run the AI workload.
Yeah. So one of the things we're looking to steal from is there's a big RHEL AI project going on right now, and one of the things that they're doing inside of that project is they're building, inside of StructLab, there's these different container files that are all about lighting up different types of GPUs. And what we want to do is take those container files, build Fedora-based images off of them, and then have those images available to Ramalama, so it'll notice that you have this kind of NVIDIA GPU, download that image, and then use that image to light up the GPU. That would be the perfect, well, actually, to tell you the truth, I think those images right now in StructLab are based on top of, I think they're CentOS at this point, but they're not big. So they are, AI Lab Recipes has all these, or StructLab has an open source. But yeah, we want to get to the point that it's Fedora. And I think the talk yesterday when they were talking about how the AMD is making this available, we want to be able to take advantage of that. But we're looking to have probably 4 different images available, one for NVIDIA, one for Intel, one for AMD, and then one for Mac, as well as, well, we just use native CPU. So if we have, he's demonstrating CPU at this point. But then have, in a perfect world, those images, we'd make those public, and when people found problems with those images, they would open up pull requests to us, and we'd be able to get it back into RHEL AI. So improvements to those packages would then be able to bubble down to RHEL AI. But the main goal, the two of us are not AI experts. We're not experts in lighting up GPUs. We're just trying to throw together a little Python wrapper on top of Llama CPP and figure out, take advantage of other people who are figuring out how to light up GPUs and then putting those things into containers and then running it. So
one thing we have in the back of our minds as well, especially because we're thinking about doing Mac. We have Mac OS builds running for this as well, so we're thinking about doing native Mac OS support. But if you want an easy life, it's containerized by default. So if you want an easy life and something that just works, that's probably the best way to do it. But we're probably going to have some kind of an option like -- no container. So if you want to manually, if you want a 10-page install guide of how to configure your GPU and install all the dependencies and run it like that, we'll leave you do that. You know.
I think the interesting thing also with the stacks of tools used to light up GPUs is they're probably going to conflict with what you have in your base operating system. So you're almost forced to use containerized tools to light up GPUs. Yes.
So I was curious, the chatbot one is always a classic example of like a model and thing that you can do and pull down. Is there any desire to work on like image generation models? And I'm not talking about containers. I'm talking about actual like pictures.
Right. So right now the tool, our goal with the tool is just to either set up a service that you could use a tool like you're talking about to run against it. So a separate project we have going is called AI Lab Recipes. And AI Lab Recipes is actually doing something similar. It's not using Ramalama yet, but eventually we want Ramalama to be the way that those tools get a service. And then, again, people who actually know AI will write code inside of AI Lab Recipes that would be able to go out there and do things like RAG and summarizer and different types of activities that you do. I think there's about 7 or 8 different ways people interact with AI models at this point. And that's the goal of AI Lab Recipes, is to give little Python code examples on how you would interact with an AI model.
I'm asking this question because I don't want Dan to throw me a curveball in the future. With the Mac enablement with Podman machine, I can understand that you are using libkern, but with the native support on Mac, are you going to use same libkern or are you going to change?
Our native support would basically tell you have to get Vulkan and everything else set up on the Mac before you run it. Oh. So native, when we say native support, we're saying we'll download the model and we'll fire it up, but we're going to run Llama CPP. It's going to expect the entire system to be configured, the GPU to be lit up and ready to run.
Okay.
Yeah, look, at the end of we have a very low dependency count. I keep Mac OS builds running for this reason. Like, we don't use a crazy amount of libraries or anything like that. And as we've referred to it's Llama CPP that's really doing the heavy lifting. So to get it running on Mac OS native, if we want to not use the libkrun solution, it's just building Llama CPP with the metal build flags on or whatever. So it's not a big deal.
So is there this question comes from, is there any skill building that we can do with the output that comes out? So upvoted, downvoted, like is there a way in future we would be able to look at whatever is generated and build a skill?
To improve the model?
Yep.
So that's not an area that the interesting, we're throwing this out as an interesting idea. So there's another upstream project called InstructLab. And I don't know if you're familiar with that.
Yes, I presented something.
Yeah, so we're not looking to compete against InstructLab, because that would be something that would probably cause our careers at Red Hat to be shortened. So right now, InstructLab is all about training. This tool is more about what we call inferencing. So in the AI world, inferencing is basically just using a model. We're not looking to make the model any smarter. And so that's where we're concentrating. Whether or not these eventually InstructLab right now is at 1,000%, the full steam ahead, and they're going nuts. We don't want to go into them and say, hey, we have a cool idea, let's look at this. So in the future, we might go to them and say, maybe we should see some symmetry here, and maybe look at merging the projects or getting the projects to somehow work better today. But for now, I don't even want to talk to. I work with the InstructLab people, but this thing they would just like scream at me if I brought this idea up. So So this is sort of a side project we're playing with.
Thank you.
Okay, we have 5 minutes, so make sure that they're not long-winded questions. All right, go with you first.
You can have a short question, might have a long answer.
Will you be calling this Ramalama in the enterprise version of this?
There's
What?
no enterprise version yet. This project's about 4 weeks old.
We renamed it Ramalama just because I heard llama. I said, "Oh, that's a stupid song I sang as a kid." Yeah, go ahead.
I really found the idea of having containerized build environment, or rather, the environment in which it runs, like RockM and Vulkan and all that stuff. Could you not also have Llama CPP containerized and layer that on top of that, or have dependent versions
Yeah,
on
no,
top of that, and then you could have an iLab one.
That's exactly the plan. Yeah.
I think it's a really good idea. It would be nice if you could have versioned of the runtime environment as well, because I know we have various projects that have reliance on particular versions of RockM and things like that.
Right. Yeah. Again, you're far smarter about this stuff than we are. 'Cause, we're looking to steal other people's tooling that they've already built. Yes.
I wanted to ask if the OLAMA registry, is it an OCI compliant registry or is it its own thing?
It's basically a brand new thing. OLAMA does basically exactly what we've shown at this point, but OLAMA seems to have a business model where they want to force people to use their registry, which is not an OCI registry.
Got it.
So it's not standard. I don't know what their long-term goal are, but we're looking at this as being an alternative to that. OLAMA also doesn't do the GPU enablement stuff.
Sure.
So that's, and what I don't want to see happen is OLAMA becomes really, really successful, and Hugging Face looks at it and says, "Oh, we'll build our own tool to do this," and then we'll end up with like 5 different tools. And bottom line, from a Red Hat perspective, our customers tend to live behind firewalls that are not going to allow their general employees to go out to pull random AI models off of Hugging Face or off of OLAMA, and we want to make it available, a tool similar to that available to them, so that they could download and play with the approved models for their enterprise.
It's an adapted OCI protocol, all right. I was looking at the OLAMA PRs very recently, and there was a PR opened in upstream OLAMA, which enabled, it was a guy who wanted to enable usage of his private OCI enterprise registry in OLAMA, and he wrote all the code. The PR was pushed 4 months ago. 0 comments.
Yeah.
So read into that what you may, but
We've lived through this in the past. All right, thank you very much. We're out of time.